Hello there. This is Moresh, and today we are going to continue with our Maths Olympiad pattern recognition solving thing. Okay, and today we are going to do problems which are a little bit more challenging, but that's what we are going to aim towards. We are going to get stronger and stronger. We are going to be fit athletes. Now, I'm going to tell you a strategy which we discussed last time around, and we are going to use this strategy to solve almost every single problem, whether it's maths, physics, science, chemistry, personal stuff, anything, almost anything in life can be solved with these three strategies. The first is if you face a big problem, first try to break it down into smaller problems. Because if you have a big problem, it can get really intimidating. It can get really challenging. Okay, how do I get past this big boulder? But if you can break the problem into smaller components, then each of these components might not be as challenging as the original problem was. Oftentimes, each of these components or sub-problems are much more simpler than the original problem, which makes them solving much easier. The second strategy is, now each of these sub-problems, okay, like problem 1, problem 2, problem 3, problem 4, they are not necessarily equally challenging. Some of them will be simpler, some of them will be harder. Don't make your life harder, do the simpler one first. Because that makes you feel good, but more importantly, when you are done with the simpler problems, you are left with more time to do the more challenging problems. But if you started with the more challenging problem, oftentimes you will face time pressure, especially in a competitive exam, let's say scholarship or Maths Olympiad. You want to do things which are easier first, because then you can pace yourselves nicely. And the third strategy, which sort of leads in from the second advice which I gave, is the answers are often not from an infinite set of possibilities. You already know what are the all possible answers. What you need to do is, oftentimes you need to pick which ones are the right answers. There will be some wrong answers, there will be some correct answers. Oftentimes, when you don't know the exact process to solve the problem, you can always go with the process of elimination. You can try whether this answer works. If it doesn't work, let's see whether this answer works, and so on. And that can give you answers in a much more faster way, rather than trying to come up with a process to actually come up with the correct answer. Let's jump straight in, and I'll show you how to apply all of these in action. All right, ready? Let's do it. Now, as we mentioned, the problems this time around is a little bit more challenging. Let's go through this, but fundamentally similar. Okay, fill in each blank with digits from 1 to 9. Each digit may be used only once, same as last time. So we have to fill these squares with numbers from 1 to 9, and you can only use each number once. The number on the left hand side, which is this number, this number, this number, this number, is going to be multiplied by 4 before adding 5 to it. So a little bit more challenging last time. Last time it was a bit simpler. I don't remember exactly what it was, but what we are effectively doing over here is this into 4 plus 5 equals this number. Now, let's start. Now, what's our first strategy? The first strategy is to break down the problem into smaller sub-problems. And let's just have a clean board. Let's make this bigger. All right. So there are effectively 5 sub-problems. This is 1, this is 2, this is 3, this is 4, and this is 5. The easiest among them, can you make a guess which one is the easiest one? The easiest among them is this one. Why? Because one side is already solved for. So let's do this. So the rule which we have is the number on the left which is 5, is multiplied by 4 and then added to 5 to come up with something that begins with 2. It's a 2-digit number, which means it's from 20 to 29. So let's see. 5 into 4 is 20. 20 plus 5 is 25. So the answer is 25, which means we have 5 over here. That's it. So let's write down our options over here first. Let's erase this. Okay, so our options are 1, 2, 3, 4, 5, 6, 7, 8 and 9, out of which we have now effectively eliminated 5. Let's get this back. Let's highlight this. That's fine. So this is 5 and now we are happy. So now the remaining possibilities are 1, 2, 3, 4, 6, 7, 8, 9. Okay. Now let's go to the next one. Can you guess which is the next easiest problem? We have already completed 1. This is done. 4 are remaining. The next easiest one is, drum roll please. This is the next easiest one. Why? Because we already know one side of the equation. In each one of these, there are variables on both sides of the equation, which makes it a little bit more challenging. But this one and this one, they have one side ready. So we only need to solve for one side. Now this one, we have 97, which is, let's say, this is A and this is B. A and B into 4 plus 5 equal to 97. If we subtract 5 from both sides, it becomes 92. So 4AB equal to 92. Now this is, I'm sort of paraphrasing over here, but it's not really AB in the strictest sense of the term. It's actually, A is in the tens place, but we'll come to that later. So AB is equal to 92 divided by 4, which is, do you know your tables? The answer is 23. 23 times 2 is 46. 46 times 2 is 92. Do your tables. Very important. Do your tables. All right. So let's erase this. And now we have second problem solved for. So 2 and 3 are done. Okay. So keep making this mistake. 2, we'll highlight it. So 2 and 3 are out, 5 is out. So our remaining options are 1, 4, 6, 7, 8 and 9. Now we have 3 problems remaining. We have this guy, we have this guy, and we have this guy. All of them are relatively complicated. This is where the tough thing begins. But do you see that this one is effectively the same problem, which means that it has 2 solutions which can work in both cases. Okay, so let's see how we can go about this. Now the numbers are 1 box becomes 6 box. Now we know 1 box into 4 plus 5 is 6 box. Now this one is in the tens place, so it's really 10 plus, let's call it x times 4 plus 5 is equal to 6 is in the tens place. 6 times 10 is 60 plus, let's call it y, 60 plus y. Okay, so We multiply this over here, 40 plus 4x plus 5 is 60 plus y. 4x plus 45 is equal to 60 plus y. 4x minus y is 15. We subtracted 45 from both sides, and y is equal to 4x minus 15. What I did was I moved the y over here and I moved the 15 over here. All right. Now, this is a linear equation which has two variables, which means it has two answers for x and y each. Now, you can't really solve this equation with just one equation, okay? And with you need another set of information to solve this. But our answers are not infinite. Remember our third rule. Our third rule is you go with the process of elimination, and that's what we are going to do over here. The process of elimination reminds us that our options are 1, 4, 6, 7, 8, and 9. Okay? Which means that y and x are only going to be out of this set. All right. Now, let's start with the process of elimination. Let's start with 9. 9 is 4x minus 15. What if y was 9? Okay. So 4x is 15 goes here, 24. In this case, x becomes 24 divided by 4 is 6. So 9 and 6 is a valid solution. Okay, so it could work. Now 9 and 6 haven't been taken, which means it could work. Okay, now let's put that in our back pocket. Let's try 8. Let's see this one. We take it over here. 8 equal to 4x minus 15. 4x is equal to 23. Now we already know that 23 is not in the table of 4. Okay, 4 times 6 is 24. We want perfect divisible because we are dealing with integers over here. They're not saying what is 1.1, fill up with 1.2, etc. etc. We are talking about no decimals, normal numbers, normal integers. Okay, so 8 is not an option over here. Let's see if 7 is an option. Let's see. 7 is 4x minus 15. 4x equals to 22. I move this 15 over here. 22 is in the table of 4? No. Which means 7 is not an answer. Now let's see if 6 is an answer. Okay. We have already seen that 9 and 6 is a valid answer. Okay. So it can go over here and it can go over here, but we want to find another set of solutions. So we have already done one solution, which is 9 and 6. Now, because 9 and 6, they go hand in hand, we can't use 6 again because in that case, we have already used it once. So we are not going to try out 6. 5 has already been tried out. So we'll jump to 4. Let's see whether 4 is a valid option. Okay. 4, this is our formula, y equal to 4x minus 15. So if y was 4, x minus 15, y can't be 4. Okay. So let's see. 1. That's the last remaining one. I hope it works. 1 equal to 4x minus 15. 15 goes here. That becomes 16. Is 16 in the table of 4? Yes, it is. We're lucky. Which means x is 4 when y is 1. Okay. So we have two set of answers over here. We have 6 and 9, and we have 4 and 1. So we put 6 over here. Let's erase this up a little bit. All right, let's put that back in. This is 5. So 16 times 4 is 64. 64 plus 5 is 69, which means 6 goes here and 9 goes here. And the other answer was 4 and 1. X was 4. 14 times 4 is, what's the answer? 56. 56 plus 5 is 61. Now, we have already covered 4 of the problems. Okay, last problem remaining, and our possibilities are, dwindling down fast, which means the last problem is actually going to be much easier. We have done 1, 2, 3, 4. All of these are gone, and 1 is also gone. Let's highlight this so we can't use it again. The only options remaining for this one are 7 and 8. Okay, so all we need to now find out is where does 7 go and where does 8 go. Easy peasy. Let's not break our head on it. We'll just try out. Just try 7 here and 8 here. If we are lucky, it might work. If we are not lucky, we'll just try again. That's fine. So let's see. 7 times 4 is 28. 28 plus 5 is 33. Doesn't really work. Now let's swap this out. Let's keep 8 over here and 7 over here. 8 times 4 is, 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32. 32 plus 5 is 37. And that is our problem solved. So how did we go about it? We didn't come up with any radical new formulas or anything. We just used basic logic and reasoning process. We broke down the problem into smaller components. We did the easiest problem first, and then we went about eliminating possibilities. Keep those 3 rules in mind and you will be good. That's it so far for today. Let's tune in again next time. This is Moresh. See you next time.